Okay, first of all, I'm very happy to be here. Yeah, and for the Germans in the room, I know my last name means goat's foot. I've known that for a long time. It's been an embarrassing thing. But I have 3 sons. Well, my wife and I have 3 sons. She did all the work. But anyway, they all played soccer, and then later on they played football. And they've been taking creatine for most of their life, since they've been 5 or 6 years old. They're currently 26, 24, 23 years old. And so I liked what Eric Rossen said during his one of his first slides about his potential conflicts of interest and bias, and that is I've been taking creatine for a long time. I finished my PhD in 1996 under Dr. Peter Lemon at Kent State, and I started in '92, and that's when, of course, the seminal paper that has been discussed over and over came out. So we started doing research soon thereafter at Kent State, and so that was sort of my introduction into the world of sports nutrition. So I'm happy to be here today, and I won't keep you long because I know everyone's hungry. In terms of disclosures, COIs, and bias, I am a member of the advisory board. I've been doing this for 25 years. So the first 15 years of my life was spent in academics as a student and a professor. The last 25, I've had my own research lab where I've done sports nutrition-related research. I've been a consultant and writer for various companies, received remuneration for that. I have a couple of patents out on the market, nothing related to creatine, more related to methyl urates and butyrate. And I don't receive any money. Despite loving creatine and taking it for a long time and doing research, I've never received a penny for doing any creatine research. In terms of what I'm going to discuss today, I'll give you a background, although it's day 4. I think everybody in the room knows what creatine is and what it can do, so that'll be very brief. In terms of benefits and effects, same. The role of creatine in muscle recovery, how creatine might impact muscle damage or muscle recovery. I'll share a couple of studies that demonstrate a lack of an effect of creatine on muscle damage. I'll share a couple of studies that show it has a beneficial effect on muscle damage and muscle recovery. And then I'll cover a couple of the recent metas and systematic reviews and go over some potential mechanisms. And so I'd just like to call your attention to the panel on the right. We started here, right, with Roger Harris and Holtman and so on. We started down here, case studies. There's a lot of cross-sectional data. Then we move upward in terms of the hierarchy of scientific evidence for any intervention. And so the peak is supposed to be meta-analyses and systematic reviews. Is that true? Well, it can be. This is a nice graphic that I found that talks about the difference between most of us in the room as scientists and then coaches, or maybe even clinicians, right? So when we examine the scientific literature, we make statistical comparisons based on group averages, right? And we determine with our t-test or our ANOVAs or so on whether or not there is a statistically significant difference between groups, right? But within each group, let's look at the left, you might see people who do worse, people who really have a neutral response, and then people who do better, right? So the conclusion of the scientist, if you run parametric or non-parametric statistics, would be that there's a likely positive effect from this intervention. But if you're a coach or a clinician, you might use published studies as a starting point, but then for your individual athletes or your patients, you might say, okay, for this first patient, I had a negative outcome. I will not use this intervention with that patient. For the second patient, athlete C, it didn't matter. But for these other 2, there were positive responses. So these 2 patients or athletes would benefit from the intervention, whereas the other 2 would not. So I guess the point of this slide is that these 2 roles are not necessarily contradictory, but as scientists, we have to realize we start here on the left by looking at the available scientific evidence from research studies, but then we fine-tune our recommendations based on the individual athlete or patient. Okay, in terms of background, we all know what creatine is, what it can do. Naturally occurring, it's found 95% in skeletal muscle. There's some in the brain. Hopefully by day 4, again, we all know that creatine started off as a great supplement for athletes who wanted to build muscle and become more explosive. Now we know that creatine has widespread effects on brain health, potentially on bone health, and so on and so on. So much more than a sports supplement. But the whole starting point was that creatine plays a role in the rapid regeneration of ATP, which we know is the primary energy currency of the cell. I don't know what the numbers are. I think Dr. Kreider shared some of the numbers in terms of the annual sales of creatine, both in the US and worldwide, but it's amazing. And Roger Harris certainly was reading the tea leaves, or he had a crystal ball, because he called it. He called it years and years and years ago. In terms of benefits and effects, again, this is review for everyone in the room. We know that creatine increases phosphocreatine stores by about 20 to 40%. It enhances ATP availability, and it's really good for team sports that when athletes undergo short duration but high intensity repeated efforts. So again, as Dr. Stout mentioned earlier, football, lacrosse, soccer, MMA, any sport that has very high intensity bursts. Doesn't mean it's not important for endurance athletes. And Scott, Dr. Forbes, I'm so sorry I missed your presentation, but I'm sure you covered that in detail. Muscle growth, we know that if you supplement with creatine over a period of time, whether it's 4 weeks, 8 weeks, 12 weeks, that you can get an enhanced training adaptation in terms of lean mass and strength acquisition and so on. Cognitive, again, we're sort of dipping our toes in the water. It's a little bit early, but we think the collective body of evidence thus far would indicate there's a potential benefit to creatine, again, depending on the dose, depending on the duration, depending on the patient or the subjects being studied. The therapeutic benefits of creatine have been looked at in various neuromuscular diseases, variable success depending on the disease process you're looking at. And then recovery, which is what I'm going to talk a little bit about today. Whether or not creatine reduces muscle damage markers, which are proxies, of course, for the recovery response, and inflammation. And as you'll see, the data are somewhat mixed. So what's the role of creatine in muscle recovery? Well, primarily, creatine supports ATP resynthesis via phosphocreatine. And we know that muscle damage basically consists of 2 events, a primary event and a secondary event. The primary event is you damage the muscle fibers, right? Exercise-induced muscle damage results in damage to the microfibers, the Z-lines and the Z-discs and the sarcomeres themselves, which compromises muscle integrity. But then there's the inflammatory and oxidative cascade that follows that initial damage. And I think that might be where creatine shines and where the most benefits are, because there's increases in pro-inflammatory cytokines, infiltration of pro-inflammatory immune cells, and so on. So therefore, effective recovery from muscle damage involves a few critical steps. First, you need to restore muscle fiber integrity. Second, you need to reduce or limit the inflammatory and oxidative stress responses to prevent excessive tissue damage and help promote healing, right? So we don't want to completely negate the training effect, right? Some disruption at the cellular level is necessary for remodeling and adaptation, and that's important. And then finally, rebuilding the muscle proteins and also the extracellular matrix, which means stimulating muscle protein and also collagen synthesis. And there's some data there that shows that creatine can help with type 1 and type 3 collagen repair and synthesis in tendons and ligaments. And why is this important? Well, because optimal recovery is essential to maintain health and performance. How many people in the room use the Consensus AI for research? Anybody? 1, 2. This is good. This is pretty good. So consensus.com, no, I'm not affiliated. I'm not a paid advisor, but it's quite good. So this is an AI and ML app online called Consensus. And I typed in the question, does creatine supplementation accelerate recovery after muscle damage / injury? And it pulled up 14 relevant papers. About half of them said yes, half of them said no, and the other ones were sort of neutral in the middle. So what do some of these look like? Well, Dr. Rossen's in the room. Eric, thanks. We talked about a study done in 2001 at UMass in Priscilla Clarkson's lab. Eric took 23 untrained men, gave them either creatine or dextrose as a placebo, and they were matched for baseline isometric strength, and then he beat the living hell out of these guys. So before he did that, they ingested 20 grams a day, which is about 0.26 grams per kilo relative to body weight, for 5 days. And then they did 2 sets. Well, 2 sets, that's not a lot, but each set consisted of 25 reps of forearm flexion, so this movement here, just the lowering part, right? Just the lowering part. Each rep lasted, I'm going the wrong way. There it is. Each rep lasted 5 seconds. So you start here and you say 1001, 1002, 1003, 1004, 1005. That's 1 rep. Maximal effort, because someone is pulling on your hand, trying to get your arm to do this real fast. So you're providing maximal effort to resist elbow extension. Make sense? Okay. Each rep lasted 5 seconds. There was 15-second rest between reps. And they looked at changes in isometric strength, plasma, creatine kinase, and also lactate dehydrogenase, range of motion, soreness, circumference as a proxy for muscle swelling. And they looked at those markers 5 days post-exercise. And so here are some of the panels. You can see creatine kinase here. There's a lot of variability in that measure. And Eric, I'm not sure if those are SDs or SEMs, but I'm going to guess they're standard errors, which means the standard deviations would probably be even bigger. So there's lots of variability in those serum measurements. Similarly with lactate dehydrogenase, and this is muscle function. And so both groups respond in a similar manner. Like I said, they beat the living hell out of these guys, and everybody was sore, and everybody got weaker, and creatine really didn't make a difference. It didn't really have any effect on the recovery response. Why is that? Eric and I spoke, and we both agreed that exercise bout was probably too severe. I don't know if non-physiologic is the proper phrase, but it's certainly not something that someone would do on a daily basis. I mean, you go out in your yard and you dig a hole and you're sore the next day. That's nothing like what they did in this study. So he did a follow-up study. He did a follow-up study a few years later. This time, instead of using untrained men, he used weight-trained men, and they ingested creatine not just before, but they also ingested creatine for 5 days after exercise. And at the time, this was 2007, Dr. Bill Kramer from Penn State was using a protocol to investigate the hormonal responses to resistance exercise. And it consisted of 5 sets of squats, 15 to 20 reps at about 50% of the max. So I'm guessing that's why that exercise bout was chosen by Eric's team. And they, again, they looked at maximal strength, plasma markers of muscle damage, and this time also they included high sensitivity C-reactive protein, range of motion, muscle soreness, and so on. They looked at all that for 5 days post-exercise, and again, nothing going on. No effect of creatine, even when it's taken prior to and 5 days after. Okay, on the other hand, here is a paper that was published a little bit more recently. Again, untrained males, a little bit of carbohydrate co-ingested with the creatine versus carbohydrate alone, 5 days prior, but look at this, for 14 days after as well, so to assist in the recovery response. They looked at, the exercise bout was 4 sets of unilateral, again, which is the lowering part only, for leg press, leg extension, and leg curl. They used isokinetic and isometric testing, again, the standard plasma markers of muscle damage. However, in this case, this was from Paul Cribb's lab and Matthew Cook, so this was done in Australia. Isometric strength was 21% higher, isokinetic strength was 10% higher, and they were significantly greater in the creatine group versus the carbohydrate control. This is the same study. This just shows the CK response was attenuated quite dramatically here. starting at about 48 hours, so 2 days post, but you can see something's going on here at 24 hours post. So the conclusion here is it works. Creatine plus carbohydrate improved the rate of recovery. This lower panel represents isometric strength, and you can see there were differences that appeared immediately, 24 hours later, and then consistently there were differences in strength recovery, isometric strength. So that's a thumbs up. So the first two studies that I shared that Dr. Rawson did were sort of thumbs down, no effect of creatine supplementation. This study is a thumbs up. There was a benefit. Here's another more recent study from a Japanese group. Again, healthy males. You see it's a consistent thing, and it's unfortunate, but there's lots of data, at least initially, in the sports nutrition world in males. That's changed over that landscape has changed over the last 5 to 10 years or so, but it's always college-age males that we start with. So apologies for that. And I think if you listen to Dr. Abby Smith-Ryan, she's been at the forefront of looking at lots of different types of interventional studies in sports nutrition using females, which is fantastic. So in this study, again, 20 healthy males, they ingested just 3 grams a day for 28 days. So based on some previous research that Rick shared and others, we know that you can get skeletal muscle creatine content to a similar level after 3 to 5 grams of creatine per day for about 30 days. Is that the best way to do it? I don't think so. I concur with Dr. Stout. I think if you want to maximize the potential benefits of creatine, it's so funny because we started off in the early 90s or in mid-90s saying load for 5 to 7 days and then drop back on your dose. And then we went to, you might not need to load, just take 3 to 5 grams a day for 30 days or every day and you're probably okay. Now we're coming potentially back full circle saying if you really want to make sure you benefit from creatine supplementation, you probably want to load for the first 5 days or so, my opinion. In this study though, again, 20 males, 3 grams a day, they did five sets of 10 reps of unilateral, meaning one arm only, again, the forearm exercise bout, and they found significant benefits on range of motion, maximal voluntary contraction, circumference, which is a proxy again for inflammation, and muscle shear modulus, which is a measurement of tensile stiffness, muscle stiffness. So you can see in the panels here, range of motion was different. Maximal voluntary contraction. The open circles are the creatine group. The closed circles are the placebo group. And so you can see significant benefits in maximal voluntary contraction, range of motion, and muscle shear. They also looked at a urinary marker of muscle damage called titin N-terminal. Titin is elastic component of muscle that connects the Z line to the M line, and it's considered to be a little bit more specific to muscle damage. So they looked at it in this study. They didn't find any differences, which is interesting, but again, they did find beneficial changes in some of the other markers, which indicates that creatine might be beneficial for accelerating recovery from this type of exercise. Okay, now let's switch gears a little bit and look at some of the meta-analyses and systematic reviews that have been done. So this is one that was done, let's see, this is Northeastern Clifford, so that's out of the UK. They looked at 13 different studies, and again, for those in the audience that don't know what a meta-analysis is, it's a way to look at a lot of studies all at once using statistical methods, okay? And in this study, in this meta, they concluded that creatine did not improve recovery from exercise-induced muscle damage, specifically muscle strength, soreness, range of motion, inflammation, and CK. This is a more recent meta that was done. This is out of Australia. They looked at 23 studies total, 13 qualified according to their pre-described criteria, total of 469 participants. Again, sorry, 90% males, once again, there it is, with an average age of 24, so young males. And they looked at a lot of different things, right, collectively all at once. They looked at eccentric, concentric resistance exercise in 11 studies, eccentric contractions only in 4 studies. They did some middle to long distance running in 4 studies, graded exercise tests, downhill running, and a vertical jump test. So they compared all of those studies simultaneously. The biomarkers that they looked at were creatine kinase in 16 of those studies, LDH in 10, interleukin 6 in 2, TNF alpha in 2, CRP in 1, interferon alpha in 1, and interleukin 1 beta in 1 study. And they also looked at markers of oxidative stress. So a very thorough meta-analysis here in terms of what they looked at. They looked at T-bars, 8-oxo-DG, glutamic oxaloacetic transaminase, glutathione, malonyl and 8-isoprostane F2 alpha in 1 study. Okay, so what did they find? The only variable here in the primary analysis that was less than 0.05, which again, for those of you in the audience who may not be a statistical expert or know a lot about statistics, in science we say something is significant, meaning it's likely to be a real effect if the p-value, the probability, is less than 0.05. So the most conservative scientists would say if the p-value is 0.06, there's no effect. Now, probability doesn't work like that. It's not supposed to be a binary decision, yes or no. It's supposed to be evaluated within the context of the exercise, the study design. And so with that in mind, it drives me crazy when I see p-values still today that just say, it was greater than 0.05. Well, what was it? Was it 0.06? Was it 0.07? What was the effect size? I want to know. I don't like that kind of nomenclature. The other thing to point out here is the heterogeneity, which is a measurement of variability in this primary analysis, was very high. An I-squared value of greater than 0.75 is considered high heterogeneity, which means lots of variability in the results. Lots of variability in the designs, lots of variability in the measurements, lots of variability in the results. So that is a caveat when they did a sub-analysis. Oh, by the way, the primary analysis said, yeah, it works for CK. It lowers creatine kinase a little, but it doesn't really work for anything else. But when you take a deeper dive, noting the heterogeneity, and you look at sub-cohort analyses, then they uncovered some lower markers of muscle damage and inflammation and oxidative stress were lower in creatine supplemented subjects. The paradox was, and you can tell by the title of the study, the paradoxical effect of creatine on muscle damage, was that creatine lowered exercise-induced muscle damage acutely, so that acute response was lower, but it didn't improve muscle soreness or recovery outcomes. In fact, some of the muscle damage markers were actually higher chronically. And so is that a good thing or a bad thing? Well, let's think about it for a second. Acute studies are good. They're a good starting point for looking at how a certain intervention might affect a subject and outcomes. But where the rubber meets the road, or the true litmus test, in my opinion, is does creatine improve training adaptations, right? If you take creatine and you exercise, because I'm an exercise guy, right? Does it improve strength chronically? Does it improve lean mass chronically? Does it improve explosive performance chronically? Does it endurance performance in some cases chronically? And the answer to that is yes. So I'm not saying that everything I shared today take with a grain of salt, but I'm saying where the rubber meets the road, the most important thing is not where you are after 1 day or 2 days or 1 week. It's where you are after 1 month, 2 months, 6 months down the road. These are some more follow-up systematic reviews and meta-analyses. You can tell most of them are pretty recent, 2021, 2022. If you haven't read this one from the ISSN, the position stand, it's a great one. If you look at these collectively, they looked at CK, improved muscle damage markers over 2 to 4 days, recovery markers, strength recovery. The bottom line is, collectively, the body of evidence seems to indicate that creatine reduces muscle damage markers and improves functional recovery, particularly acutely. But that nuanced finding of increased muscle damage markers chronically highlights the need for smart, balanced training and recovery strategies. Are there any dietitians in the room, or anyone, a nutritionist or a dietitian? No? Well, I can tell you that I'm not either, but in our studies, it's always a good idea to capture nutritional data, right? So what's someone eating during the study and during the recovery period? So for example, if they're eating fried foods, which are pro-inflammatory, that's going to affect their recovery response. If they're eating a bunch of salmon and broccoli, foods that are anti-inflammatory, that's going to affect the recovery response. So without a firm handle on dietary intake, both prior to the exercise stimulus as well as in the recovery period, it's very difficult to draw firm conclusions. And I can tell you, because I've been doing this research since, again, the early 90s, people lie about what they eat. They lie about how much they eat, what they eat, how much of it. Dietary records are notoriously unreliable, unfortunately. The only real way to get a good handle on what someone eats is to provide their meals for them and then have them take pictures of what they ate or what they didn't eat. And as you can imagine, that's incredibly expensive and incredibly time-consuming. Okay, so if creatine works to enhance muscle recovery and improve muscle damage, what might be some of the mechanisms? Well, there's a few. ATP resynthesis is a no-brainer. We know that from cellular studies early on. Reduction in inflammation and oxidative stress. Some of those inflammatory markers and oxidative stress markers have indeed been shown to be attenuated by creatine supplementation. There's the idea, and Dr. Stout mentioned it too, with muscle cell hydration, that creatine might increase, acutely at least, intracellular water, and that stretch of the cell membrane can promote increase in protein synthesis. Funny story, when I was getting my PhD at Kent, creatine was my project, my dissertation, and I did 3 separate studies. The first study was on D1 athletes, Division I athletes. Does it improve explosive performance in Division I athletes? And it did. And I used men and women, by the way, and it did. The second study was using N15 glycine as a stable isotopic tracer. Does creatine affect whole body protein synthesis and breakdown? And this was done, I finished in '96, so I had these data back then. Didn't do anything to protein synthesis, but it reduced protein breakdown. Didn't publish it because we only had a few subjects. It was N of 6, I think, or something. But way back then, we had some early indications that creatine might be working on the side of protein breakdown instead of protein synthesis. So if you read some of the recent research out there, and you look for, or if you type into consensus, does creatine supplementation increase muscle protein synthesis? You're going to find that the data, again, are mixed, and there's no clear indication that creatine increases muscle protein synthesis. How is that possible? How does creatine, if you take it chronically, increase lean mass, but it doesn't increase protein synthesis? Where's the lean mass coming from? Interesting question. And so that's the protein synthesis part at the very end. But we do know from studies that have been done, sure, you can see increases in myogenic regulatory factors, IGF-1, satellite cell proliferation. Those are all there. All those signals are there. But when you look for, again, MPS, muscle protein synthesis, you don't get it a lot of times. So this is I just wanted to highlight the study done by Ben Wax and pub by Ben and Chad and Dr. Kreider. This is a great paper if you haven't read it. This is, was this pubbed in, what's the date on this one, Rick? Sorry, 21. So this is a relatively recent paper, and it looked at exercise and sports performance and then recovery considerations, not just for athletes, but also for healthy populations. And so the conclusions from their paper was that there's very strong evidence that the increased ATP availability is a primary mechanism whereby creatine might be beneficial. There's moderate evidence that antioxidant effects are happening. There's also moderate effects that anti-inflammatory effects are happening. MPS, as I mentioned, maybe moderate, maybe a little less than that. Calcium homeostasis, weak. We need more data here for sure. Enhanced glycogen storage. I'm sure Dr. Forbes mentioned that if you're an endurance athlete and you carbohydrate load, if you take creatine while you carbohydrate load, you can load more carbs into the muscle, right? Very, very, very beneficial. Let's not forget that. And again, I just want to call attention to this last, the extracellular membrane, or excuse me, the extracellular matrix, because creatine has been shown to upregulate, again, type 1 and 3 collagen synthesis, and so that could be a potential mechanism as well. So, in conclusion, is there definitive evidence that creatine can reduce muscle damage and improve muscle recovery? No, but I think the collective body of evidence, it's not a slam dunk, but I think the collective body of evidence says, in general, yes. Yes, it can. I didn't get a chance to cover any muscle injuries like strains. We need a lot more research for that. And again, I think if you're going to use creatine, load and then drop back to your 3 to 5 grams per day. And I also think dosages based on body weight, which again, the doctors Candow and Forbes and others have been promoting for a number of years now, instead of just saying 3 to 5 grams a day, dosages adjusted to body weight. The more lean mass you have, the more creatine storage depots you have, it probably makes sense to take more than if you're a 50 kilo person. So 100 kilo male, 50 kilo female, same dose? No, I don't think so. I'd like to thank AlzChem for hosting the conference, especially Robert, you've been great. The advisory board, Rick, thanks for inviting me, the session chairs, all the presenters, the attendees, thank you for your time.